Hello there, Mr. Sutton bringing you the first in a series of lessons on matrices. In this one, we're going to learn to add and subtract matrices and to multiply them by scalar values. We'll also be performing translations and dilations with matrices, and for our real-life application, we're going to move and resize a character in a video game. Let's begin by talking about some basics of matrices. A matrix of order m by n is a rectangular grid, like this one, of elements, that's each of these individual things in here, with m rows going this way, and n columns, these are columns here. So notice that the way we name the dimensions of a matrix, it's always rows and then columns. And there's also a naming convention for each element. Notice element here 2, 3. This is the element in row 2, column 3. So row before column, even in the names of the subscripts of the elements. As another example, let's say we have a 2 by 3 matrix. That means we have a matrix with 2 rows and 3 columns, like this one here. And if I want element 1, 2, this is 1, 2, not 12, that's asking for the element in row 1, column 2, so 23. One more important definition here, and that is the identity matrix. This is a special square matrix where you have 1s going diagonally down and 0s everywhere else. Now, this one isn't going to be so important in this particular lesson, but later on when we do systems and inverses, this is going to be very important. So stay tuned for more on this in future lessons. Let's take a look at some operations now with matrices. In this one, we're adding 2 matrices together. To do this, it's actually pretty easy. We just have to add the numbers into corresponding elements together. In a lot of ways, this is really a lot like adding vectors together. So this 2 is going to get added with the negative 1 because these are both in the upper left spot, and then 9 plus 5, 0 plus negative 1, and so on and so forth for these bottom 3. All right, let's go through one at a time here. So we've got 1, 14, negative 1, negative 7, positive 8, and positive 4. So you might be wondering, well, what do I do if I have different dimensions? Like if this is a 2 by 3 already, but let's say that this one here was a 3 by 2 or a 1 by 10. Well, you can't add matrices with different dimensions together because if you don't have the same spot for both matrices, I mean, what are you actually adding together? So got to have the same dimensions. We're going to take our operations a step further by including some scalar multipliers now. So to deal with these, it's actually just like when you had vectors. If you had a multiplier outside of vector, you just multiplied by each item in there. So we're going to do the same thing here. We're going to distribute this scalar to all the elements in each matrix. Pause the video and take a moment to do that. And then if you're feeling really ambitious, go ahead and subtract the matrices that you get from doing that. All right, let's see how you did. So first we'll do our first matrix here, multiply everything by 3. So we have negative 3 in the upper left, and then negative 6, 24, negative 15, 0, 6, negative 6, 27, and negative 12. Over here, I had a choice. I could have multiplied everything by negative 4 and made this a plus, but I'm choosing to just multiply by positive 4 and keep the minus here, mainly because we haven't done subtraction yet. So I've got 4 times 3 is 12. And we have negative 16, negative 36, 20, negative 8, negative 28, negative 8, 12, and 0. Next, I'm going to go through and subtract everything that's in the same spots. So we have our upper left here, element 1, 1. So negative 3 minus 12 is negative 15. And then we have negative 6 minus negative 16. So that's plus 16 or positive 10. These upper right spots will be, let's see, that'll be 60. And then we're going to have negative 35, 8, 34, 2, 15, and finally, negative 12. So how can we use this stuff in real life? Well, let's say video game designers are creating a game starring Triangle Man. Triangle Man starts in the location negative 4, 1, negative 2, 5, and 0, 2. 1 point for each of his 3 vertices. To fight his arch nemesis, Rhombus Raccoon, Triangle Man wants to go to 3 times his original size and teleport 5 units right and 2 units down. What would his new coordinates be? So to state the problem more officially, we've got these 3 points of a triangle, and we want to perform this transformation, increase by a factor of 3, and then shift 5 units right, 2 units down. How are we going to do this? One way to do this is to use matrices. So we can start by creating a point matrix, and I'm just going to make the top rows x's and the bottom rows will be our y values. So in the top row, we've got -4, -2, and 0. In the bottom row, we have the y values 1, 5, and 2. Next, we're going to multiply that by 3, so stick a scalar value of 3 out in front. And if we want to translate it, well, then we can add a translation matrix. So this translation matrix just has what you're going to be adding to all the x and y values. If we're shifting 5 units right, we want to add 5 to all the x values. So we're going to have 5s in the whole top row of this translation matrix. And then if we're shifting 2 units down, we want to add -2 to all the y values. So we'll have -2s in the bottom row. And what are the dimensions going to be? Well, they'll have to be 2 by 3 so that we can add them with this first matrix. So there's our translation matrix. Pause the video and go ahead and perform this operation here. All right, first step, we got PEMDAS, right? We have to do multiplying before we add. So this will be -12, -6, 0, 3, 15, and 6. And then adding that with our translation matrix. So this is the dilated triangle man here. Now we have to move him. We've got -7, -1, then we'll have 5, 1, 13, and 4. But we're not quite done. We're going to use this new matrix and write some new points based off of this. So we have the point -7, 1, -1, 13, and 5, 4. So one of the advantages of doing this is a very systematic way to deal with a bunch of points. With 3 points, it might have been just as fast just doing this kind of by hand with each of the 3 points. However, if you had, say, 50 points or 1,000 points, matrices allow us to automate a lot of this and let computers do a whole bunch of it for us that we wouldn't be able to do if we were just kind of ballparking this by hand. Well, I hope you enjoyed our lesson on matrix operations. Until next time, this is Mr. Sutton signing off. Triangle Man, Triangle Man.